Hello world. Welcome to my YouTube channel. I'm the Universal One, and in this channel I inform you all the latest info on the current updates and discoveries about our universe. So if you care about the universe, be sure to subscribe, like the video, share it to all your friends, and let me know your thoughts in the comments section below. In this video I'm going to be explaining to you the superiority of black holes over white dwarfs. Even though there is similarity in their formations and origins, black holes are so much more dominant and have more energy than their counterparts in the cosmic space. Yes, in general, black holes are more massive than white dwarfs. The key difference between these two celestial objects is their mass and the processes that lead to their formation. Black holes are typically formed from the remnants of massive stars. When a massive star exhausts its nuclear fuel, it undergoes a catastrophic gravitational collapse. If the star's core mass exceeds a critical threshold, approximately 2.5 to 3 times the mass of the Sun, it collapses into a singularity at the center of the black hole. The surrounding region is the event horizon, beyond which nothing can escape, not even light. This singularity has an extremely high density, effectively an infinite point. White dwarfs, on the other hand, are the remnants of stars like Alpha Centauri, which are less massive than massive stars. When a lower mass star exhausts its nuclear fuel, it expands into a red giant and sheds its outer layers. The core, primarily composed of carbon and oxygen, then collapses under gravity's influence. However, unlike a black hole, the collapse is halted by electron degeneracy pressure. This pressure supports the core against further gravitational collapse. As a result, white dwarfs have high densities but are not as massive as black holes. To put it into perspective, while black holes can have masses ranging from a few to many times that of the Sun, including supermassive black holes found in the centers of galaxies, which can be millions to billions of times the Sun's mass, white dwarfs have masses comparable to our Sun. In terms of mass, black holes are generally much more massive than white dwarfs due to their formation from massive stars. Black holes are regions in space where gravity is so intense that nothing, not even light, can escape their grasp. They are formed when massive stars exhaust their nuclear fuel and undergo a catastrophic collapse. Black holes are typically formed through the following process. A massive star, much more larger than our Sun, reaches the end of its life cycle. The star's core, no longer able to support itself against gravity, collapses in on itself. If the core's mass exceeds a critical threshold, approximately 2.5 to 3 times the mass of the Sun, it collapses into a singularity, a point of infinite density, at the center of the black hole. Surrounding the singularity is the event horizon, an invisible boundary beyond which nothing can escape. There are 3 main types of black holes. Stellar mass black holes, formed from the remnants of massive stars. These typically have masses between a few to around expels into a red giant and sheds its outer layers into space. The core, which is primarily composed of carbon and oxygen, collapses under gravity's influence. The core stops collapsing when electron degeneracy pressure halts further compression, preventing a complete collapse into a black hole. White dwarfs have the following characteristics. High density. Despite being similar in size to Earth, they are incredibly dense, with masses comparable to the Alpha Centauri. No fusion. White dwarfs no longer undergo nuclear fusion, which is why they do not shine like normal stars. Gradual cooling. Over time, white dwarfs cool and dim, eventually becoming white dwarfs with no more mass. White dwarfs are observed through telescopes and are identified based on their characteristics, such as their spectrum and luminosity. They often exist in binary systems with other stars. In summary, black holes are extreme cosmic entities where gravity is so intense that nothing can escape, while white dwarfs are the end-stage remnants of lower-mass stars supported by electron degeneracy pressure. Both provide unique insights into the life cycles and properties of stars and the strange phenomena they can create in the universe. That's it for this video. Thank you very much for watching. Subscribe to the channel for more uploads.